Okay, so that is about chapter 4 for the education industry. Last solution is about a smart grid, the electricity grid solution. Here is the composition of a typical power system. It is composed of power generation. Okay, it may be from wind, or from soda, or maybe from these different ways for the power generation. Okay, after power generation, then transmission, power transmission going through the line, okay, high volt line, and then to the power transformation station, power transformation. After this, it goes to the power distribution. There are a lot of such distribution stations. Okay. After the distribution station, then it comes to the users. Okay. The users may be home, or maybe office, or maybe some enterprise. Okay, so these are the power network, power system. And they need the communication. Communication is realized by RTU, remote terminal unit, RTU, for the communication. Of course, they need a network for this communication, right? This network may be using fiber, may be using wireless. They have the application for scheduling for workers to do some work with the grid. Communication server, some different part they need to communicate with each other, communication center, and application servers. Some data need to be collected by the application server. So these are the composition of this power system. They need a different type of services. Like they need the service for the intelligent distributed power distribution automation, automated distribution. They need the millisecond level precise load control. They need a low voltage power consumption data collection from the meter, electricity meter, for a lot of homes. They want to have the distributed power supply, monitor this, like a wind or soda power supply. So different service may need different network performance. Some they need low latency. Some they need the connection number. For example, for the meter reading, they need a huge number of connections, okay, which may need MMTC. Okay, and for the distribution automation and load control, they need the URLLC with very low latency. So this our 5G network can support the end-to-end slicing, including the access network slicing, barrier network slicing, and core network slicing. And also, our network structure can support CUPS. Our application can be deployed at the necessary position. For example, for the URLLC position scenario, this application will be deployed at the edge cloud. And for others, some which are not latency sensitive, application can be deployed at the center cloud. Okay. So 5G is very suitable for the grid because it can support plenty of service types which can guarantee their requirement for the communication. And here is for the video surveillance for the grid. This one is one robot for the inspection to check their devices with the camera. This camera may be using visible light or maybe using infrared, collecting the video. There are also a video camera for the on-site construction management and control. And for the distribution room, this camera for the monitoring of the device and their room security. So there are large number of requirements for cameras for the grid, system. You need a large number of video surveillance. And also, for the transmission line, they need the inspection, routine maintenance. And nowadays, it is using UAV for the line inspection. And at the past time, this work is done by workers. The worker will step on the line. Okay, it's very high voltage. Workers will step on the line to check whether there's problem. It's very hard job, very dangerous, and low efficiency. And using this UAV, it can save the cost, and it can make the efficiency much higher. Okay. So for the UAV, usually it's using this 2.4. This is unlicensed frequency, public frequency. Our Wi-Fi, our Bluetooth, using this frequency, right? Okay. Our mouse, okay, wireless mouse, all using this frequency 3 to be used. So there may be interference. It's easy to get interfered using this frequency. Using this frequency, the range, you see here, it has a remote control or controller console. This communication range can be 500 meters using this 2.4. And if this is a military frequency, if you use military frequency, it can be 7 kilometers. But it is only used for the military. The grid cannot use this frequency, right? Or if you use the type of DJI light bridge, this communication range can be 2 kilometers. So nowadays, just the console and the UAV directly communicate. So this range is limited. The range is just around 500 meters to 2 kilometers. And outside this range, the UAV may be lost. Okay, so this will affect the efficiency for the inspection. And in the future, when we use 5G, then we can control the UAV through our 5G network. Okay, the remote controller communicate with the 5G network, and also our 5G network then forward this information. Okay, using the MEC. Okay, to lower the latency. Okay, MEC mobile edge computing. Okay, and then this UAV can travel a long distance because we can have a continuous coverage of the 5G, and it can have handover. So in this case, the limitation of the range is not a problem. Then this UAV can fly much longer distance, and this can enhance the efficiency for the inspection, video inspection. Okay, so this is one very useful usage using 5G network for the inspection of the transmission line. Okay, so we have discussed a lot of the industry solutions. That's okay. So that's all of today's content. Thank you very much.